Good morning, everyone. I hope everyone's having a great start to reInvent. And first of all, welcome. Thank you for choosing to be here with us for the next 1 hour. We understand there are a lot of interesting sessions happening out there. So before we delve into today's topic, I just want to quickly set agenda as to what this session is and is not about. This session is not about any specific product or service or any specific technology or architecture pattern for that matter. You're going to be attending a lot of those deep dives through the week. Instead, as you begin your week here at reInvent, navigating through all the announcements of all the products and services, and exploring all the solutions and the innovations that our partners are showcasing at the expo, and of course, not to mention all things Gen AI and agentic AI, we realized it can be very overwhelming. So keeping that in mind, we designed this session to help us as a cloud community of technology practitioners and decision makers to collectively take a step back and gain a meta perspective about technology choices and technology systems architecture. And secondly, we want to leave you all with a simple mental model and a practical framework using which you can deal with technology, especially in this age of constant technology disruption that we live in. So with that, my name is Mukund Rao. I'm a worldwide partner solutions architect at the Technology Consulting Center of Excellence here at AWS. And over the last 5 years, I've had the opportunity to work with hundreds of customers across different size and scale and industries, and also with some of our strategic AWS partners to help our customers undergo what we call business transformation through technology modernization. And including my time here at AWS, I've spent about 16 years on the AWS ecosystem, and most of it I spent as a hands-on engineering architect and as an AWS customer building and scaling things on AWS. So it's exciting for me to be here and sharing my perspectives. And I have with me Sushant. So the way we are going to structure today's session is we are going to start with why. I am going to be setting the context on why do we need capability framework. And then Sushant is going to dive into what is the capability framework. And then we are going to apply this framework and trace through a couple of practical examples and use cases. And then we're going to discuss some FAQs, and then we're going to wrap it. So that's the structure today. All right, let's begin. And let's actually begin by rewinding our clocks by about 2 decades to 2005. And back then, as technologists and builders, our lives was much simpler because we had fewer choices to make. Back then we had a handful of programming languages. A server simply meant an application server or a bare metal machine, and relational database was all and satisfied most of the use cases. And even with architectural patterns, we lived in the era of simple 3-tier architecture with your presentation layer, your application layer for your business logic, and your data layer, and that's it. And if you had to scale these systems, it simply meant that you threw more resources at them, whether that is CPU or memory, and you vertically scaled these systems. Of course, that was not the most efficient way to scale. It had its own set of challenges. But the point is, we live with a lot of technology constraints, and these constraints actually forced clarity. So we were more deliberate and intentional about our technology decisions, and our systems were easier to reason with, isn't it? And fast forward to today, we live in a world with dizzying array of choices with most things in life, right? I mean, take something as simple as water. And if you walk into any nearby supermarket in a hydration aisle, you can find yourself surrounded with so many options, water, sparkling water, soda, energy drinks, sugar-free, sugarless, what have you, right? The same applies to technology as well. We actually live in an era of technology abundance. And if you take something as AWS, we have about 240 plus fully qualified services today. And this list is likely going to grow with all the announcements that's going to happen through this week, right? And if you take something as simple as compute, other than 900 permutation and combination ways of launching EC2 instances of various types and sizes, you also have the container orchestration platforms, you have serverless options, and so on, right? And even data, what was once a relational database, we now have a plethora of options, and we live in the era of polyglot persistence, or purpose-built data engines, right? So we have document storage, we have time series database, and increasingly now, we are starting to notice increasing use of vector databases and knowledge databases, supporting new class of applications, right? So it's not just the services. And when you look at our marketplace, we have about 25,000 products and services that has been published by more than 6,000 independent software vendors. So that's a massive amount of choice of services and solutions, right? And it's not just the services and solutions. The architectural landscape itself is expanding, right? What was once the simplicity of a three-tier architecture, now we live in the era of cloud-native architectures with highly distributed microservices, application mesh, event-driven architectures, real-time streaming architectures, and now developing agentic application patterns, right? Even on the data side, for that matter, what was once a traditional data warehouse, we now have modern data architectures. We have data lakes and lakehouses and medallion lakehouses and zero ETL architectures. And it's not just with application and data, right? You can even take security and other domains, and there are so many patterns like zero trust security, etc. So there are so many architectural patterns available out there. While having this choice, whether it is of services or solutions or architectural patterns, is great, right? It has, of course, unlocked a lot of potential for a lot of businesses out there, but it has also multiplied complexity, right? And it has created a new kind of challenge, what we call the choice paralysis. So what is happening as a result of this challenge is, businesses, instead of building and delivering value using technology, they're just stuck in this maze of technology. They're lost in internet searches. They're stuck in documentation, and they're taking architectural guidance from opinion-based internet forums. And as a result, they're evaluating multiple vendors, resulting in long evaluation cycles, POCs that never see the light of the day. Overall, there is a delay in value realization from technology that we are noticing, right? And on top of it, add to what we call as the shiny new toy syndrome of businesses wanting to adopt every new technology pattern out there, right? It has created, a couple of consequences. One is there is, they end up creating solutions for which they have to force fit problems, right? And secondly, they end up creating sprawling and inefficient architectures that contribute to, consume more resources and contribute to waste. So it's also a sustainability issues. So this is the state of technology and technology architectures today. Abundance has caused a lot of problems, right? It's also worthwhile to take a look at the relationship between technology and business, because at the end of the day, the objective of any technology is to support a business outcome, right? And as you can see on the screen, over the past few decades, the relationship between these two entities has dramatically changed, right? And in today's day and age, having a technology-led differentiator, is no longer sufficient. This was kind of very normal, probably like a decade ago, but having a technology-led differentiation today is not sufficient. And what we are noticing is, increasingly technology is becoming the front and center and at the core of every digital-first business out there. And it's a trend that we continue to notice, and it has accelerated since the pandemic, right? And as a result, businesses are having to, and add to this the macroeconomic conditions, right? The kind of very dynamic world that we live in today, with the increasing AI workforce, companies are having to do more with less. They are having to innovate faster, and they're having to compete harder, right? So given this scenario, it's becoming extremely important to be able to translate the business intent into technology choices, and much more faster at it than ever before, right? But let's be honest, when we talk about business and technology, them aligning with one another and moving in lockstep and all of that, for us AWS architect, it sounds very cliched. It sounds like one of these oldest lines in digital transformation playbook that gets repeated over and over again, right? But the reality is this, right? From our vantage point as AWS architects, we notice that the businesses out there are surrounded and paralyzed by technology choices, and constantly weighed down by increasing complexities of their architectures that are becoming distributed and dynamic. And add to this the new building blocks being redefined by Gen AI. It is contributing to more choice, and it's amplifying the problem further, right? So given this context, there is a need to refocus our attention on a very fundamental yet a very critical concept called the evolutionary architectures or evolvable architectures. Now, this concept of evolutionary architectures is not new. It's been there in systems design since the 70s, but it is especially more important and relevant and urgent today because of the barrage of AI products and services and tools which continues to confuse a lot of businesses out there. And then when we talk about evolutionary architectures, it also means that we need to rethink at how we look at our architectures. It's no longer sufficient to look at your architecture and say, okay, it's an integration and a bunch of like tools and services working together. Rather, we have to start looking at them as living systems, and we need to actually have a plan to continuously, cost effectively, and efficiently evolve them. So that is the biggest mindset shift we need to do for us to rethink how we look at architectures. And to do that, what we're going to do today for the next few minutes is we're going to take lessons from a couple of sources, right? So one is, of course, the lessons from our own customer journeys. We notice all sorts of customer journeys on AWS, from migration and how they go on to modernize, how they go on to become fully cloud native, and all the tactics that works and that doesn't work, so we get visibility into that. And secondly, we are going to be drawing some lessons from evolutionary biology, because nature has been here conducting experiments in evolution for millions of years, much before any of us humans existed or any of agentic AI technology existed, right? So with that, I want to highlight this timeless quote from Charles Darwin. And he says, it is not the strongest or the most intelligent of the species that survive, but it's the most responsive to change, right? So this is a very profound and a very timeless quote, and this applies to technology and technology architectures as well. So that brings me to the first lesson, or the first takeaway from today, is around architectural adaptability. And when we talk about architectural adaptability, when we look at nature, you can see that evolution doesn't happen overnight. It takes millions of years to evolve. And the same applies to technology as well, right? Architectural evolution is not an overnight journey. It happens in phases. Not implying that it should take millions of years. That would defeat the whole purpose. But I'm implying that there needs to be an adaptable set of changes, right? And when we talk about architectural adaptability, there is one thing that is very revealing and one factor that actually tells how well customers are doing adaptability good or not, and that is the success rate of their modernization initiatives. And what we have noticed is, for the customers that are most successful on AWS, they actually treat modernization and adaptability and evolution as a continuous process. They have a plan for it, and they end up doing incremental changes. That's the key word here, right? Incremental changes. And the contrary is true as well. You know, what we notice is majority of the organizations actually fail at modernization efforts because they either try to boil the ocean, or they try to do everything at once and they try to rewrite the systems without an actual plan to organically evolve your architecture. So that is one of the biggest things I want you to remember. Adaptability is the key. The second lesson is around what I call the cost of evolution. And that cost is usually paid in terms of tech debt. Now we know what is technical debt, and it can come from many layers, right? It can come from application layer, it can come from data layer, it can come from poor documentation, it can come from fragile integrations of different services. But whatever it is, technical debt, like financial debt, is not all that bad, right? As long as you have a plan to intelligently incur it and pay it off. Right? And you don't want to acquire a big debt and that will sink you, just like financial debt, right? And it's also important to be able to measure the technical debt, because if you don't measure technical debt, you end up acquiring unknown costs, right? And this visual here explains this vicious cycle really well, right? So if you don't have a plan to evolve and you're not thinking about proactive adaptability and making incremental changes, you end up acquiring technical debt today or tomorrow or whenever it is, if you're treating your architectures as static systems, right? That will result in more complexity, and that will feed into the cycle, and this goes on and on, And we have noticed there are many organizations, they don't treat technical debt as importantly, as seriously as they should, and over a period of time, because of how unmaintainable their system becomes, it starts showing on business outcome as well. So it's very important to address the technical debt. Now, the third lesson and the final lesson is around what I call as the locus of evolution, right? So far we have established why do we need evolvable architectures, and how do we go about evolving our architectures by making small adaptable and incremental changes and addressing the cost debt. Naturally, the question comes, how do we evolve the architecture, and around what do we evolve our architectures around, right? So when that question comes, the natural inclination is going with technology, right? And that is unfortunately the reality that we see with many organizations out there, right? But as we just discussed, if you anchor your architectural evolution with technology, you're going to be chasing a moving target, because whatever is latest and greatest today will be obsolete in a few years from now, right? So instead, the right way to do evolution is to anchor what we call capabilities as the center of your architectural evolution, and that's going to help you evolve your architectures much better. And to learn about what capabilities are and what this capability framework is, I now invite upon Sushant.
Thank you, Mukund. Hi, everyone. My name is Sushant Mangalore, and I'm a solutions architect here at AWS. I work with independent software vendor customers who build software and SaaS products for large-scale consumption on AWS. Prior to taking on this role, I used to work as a software architect or an application architect. And I see many parallels between cloud architecture and software architecture. Your software and the infrastructure that it runs on come together to deliver a unified experience to your consumers. Your consumers don't see them as two separate things. They consume them as one. So borrowing some lessons from software architecture can be really useful in defining your cloud architecture. And you'll see this as a theme as we progress through this session today. So with that, we want to provide you a mental model of 3 C's, starting with the first C, which is capabilities. So think of a typical enterprise. An enterprise can have one or more workloads. Now, we define a workload as a collection of resources and code that come together to deliver business value. But from that definition, a workload could be something as simple as a single-page application, or it could be this large, sprawling, complex system with many moving parts. Imagine something like a CRM solution, an e-commerce system, a banking solution. For some organizations, one workload could be their entire business, right? So when you're architecting such large and complex systems, it helps to break down or organize your workloads by smaller, more manageable portions and targeted solutions for each of those portions. So with that, I want to introduce to you the idea of capabilities. So workload capabilities represent business intent for the portions of the workload that you have determined to be your capabilities. And these are what I call logical subunits that you can independently solution for. The capabilities represent the business intent or things that your business need to deliver for a sustained period of time. And you can choose to implement these capabilities with one set of technologies today, but you retain the ability to switch out these technologies as newer, faster, cheaper, more efficient options become available in the future. And it inevitably will, right? So that way, you are taking an approach where you can independently evolve capabilities, and that way, from individual evolution of capabilities, your workload stands to benefit as a whole. Now, you may have heard the word capability in many different contexts, but for the rest of this session, we will use the word capability to mean logical portions of your workload with well-defined business intent. Now, at a workload level, we have the well-architected framework, and this baselines your workload across common architectural dimensions that are defined by the 6 pillars of well-architected framework. Now, you may be familiar with the idea of well-architected framework as a review mechanism to identify and address high-risk items that are affecting your workload. However, the principles and guidelines that make up well-architected framework are all there for you to be used at any point in time. So you can use them even during your planning and design stage. And the earlier you adopt the well-architected framework, the sooner your workload is on its way to being well-architected. So by the time your workload hits production, it's already halfway there in terms of being well-architected. So well-architected gives you that foundational layer, and upon the well-architected foundation, you can architect individual capabilities and provide targeted solutions to them. So how do you organize your workload into capabilities? So we have a few different techniques that work very well. The first one is business ownership. This is especially applicable to very large workloads. Think of something like an e-commerce solution. The product recommendations capability may be owned by the product marketing department. Customer support chatbot may be owned by customer success. And each of these business units will have their own success criteria, their own business goals, their own budget, their own skills and staff. And this way you can draw boundaries around these functionalities as capabilities. Now this can sometimes run up against Conway's law. And Conway's law states that businesses build software that mirrors their organizational communication structure. Now, if your organization is already building teams that align with business, then it is usually simpler to arrive at your architecture to make sure that the business intent is being met. If you have very large technology centers of excellence or technology-aligned teams, sometimes the technology choices made by those technology-aligned teams can influence or even limit how you achieve your business intent. It's a hard problem to solve for sure, and it's not something that we are really going to be able to solve here, but just something to keep in mind as you organize your workload by capabilities. The next technique borrows from software architecture and uses the idea of domain-driven design, or DDD. So DDD promotes this idea of organizing your workloads by bounded contexts, and each bounded context represents a business domain. Event storming is a popular technique by which you can identify your domain boundaries or bounded contexts. And this is a one-day workshop where key stakeholders come together and work together to identify the bounded context. And once you identify these bounded contexts, they can become your workload capabilities. The next technique is less formal than DDD. It just makes use of basic good architectural practices. And I would call it Architecture 101, if you will. Right? So it brings together related functionalities that achieve a common objective and groups them into a capability. So this is what I would call functional cohesion. And once you identify capabilities in this manner, you would wall them off from other capabilities within your workload, loosely coupling them. So we are making use of coupling and cohesion as two driving factors to identify our capabilities. And this way, each capability can be operated and evolved independently. And the last technique I want to talk about here is distinguishing traits. So distinguishing traits are portions of your workload that exhibit certain qualities that set them apart. These usually translate to your competitive advantage or business differentiator. Imagine offering something like the easiest insurance quoting process or the fastest checkout in e-commerce. These are all reasons why someone will use your solution over something else that's out there in the market. Right? So once you identify portions of your workload that need to be solutioned with distinguishing traits in mind, you can draw your boundary around those functionalities as your capability. Now, irrespective of how you slice up your workload into capabilities, you'll see that distinguishing traits really matter, as we talk about this later in the session as well. And you can use either one or a combination of these techniques to arrive at your capabilities. But just keep in mind that the idea is to not wholesale solution your workload as one giant thing, but instead slice them up into smaller portions, making it easier to solution for them. In the absence of something like this, it's very common that you try to solution with a broad stroke of brush. You try to standardize with a common set of technologies across your workload or even across your enterprise. And that can lead to a situation where your technology choices are suboptimal for portions of your system where better options may exist. All right, so now that we know how to break your workload into capabilities, let's talk about what makes up a capability. All right, so capability is made up of two factors: sounds straightforward enough. So there is functional requirements and non-functional requirements, NFRs. So functional requirements are well understood. Usually they are well stated. Your product team talks to your business, documents them in the form of epics, user stories, requirement specs, and your engineering team goes and builds them. NFRs, on the other hand, although everybody realizes the importance of NFRs, having security, availability, performance, these all matter, but usually they are not well stated in advance, and your engineering team has to discover them and ensure that these are not an afterthought and not bolted on later. So what our approach promotes here is elevating non-functional requirements to first-class status. They should be at the forefront of any technology decisions that you make. So what happens when you do not have non-functional requirements well stated by your business? So in that situation, you need to discover or elicit them. So the technique that we use here is called dialogue-based discovery. Now, the business intent can exist at multiple levels. At a workload level, they usually align with some sort of a CXO objective or a board-level objective. You want to improve your profit margins. You want to increase your top-line revenue. Or it's some sort of a risk reduction initiative or a compliance initiative. At a capability level, the business intent tends to have a leaner focus. So you would talk to your business and try to understand what they are trying to achieve with any given capability. And you will hear terms like this. Let's take, for example, that you want to improve your customer satisfaction. Now, customers could be dissatisfied for many different reasons. You may find that shopping carts are being abandoned. You may find that you're getting a lot of incidents and tickets. You're getting a lot of complaints. Right? But as architects, we need to understand what is causing this dissatisfaction and ask business more pointed questions like, hey, are the users seeing errors in critical user journeys? Is the application slow? Is the application unavailable when they need it? And through these kind of questions, we can discover our non-functional requirements by arriving at certain qualities. Right? So each of these statements that business has stated in plain English can result in non-functional requirements. So in the customer satisfaction scenario, we ended up with performance, resilience, and availability. But these are not by no means exhaustive. Right? There could also be other reasons like usability or responsiveness of the system, which could be causing user dissatisfaction. Now, this alone is still not sufficient for engineers to go build. You need some concrete metrics or SLOs to chase. So you dive a level deeper and ask more pointed questions that, is it okay for the page load time to be 2 seconds, 99th percentile time? Is it okay for the system to be unavailable for a few minutes, 5 minutes in a month? And that will lead you to more concrete SLOs that the engineering team can now go chase. So that's how you arrive from your business intent to your non-functional requirements. But imagine you come out of a conversation with your business and you end up with a dozen NFRs, right? Everything sounds great. We want performance, we want security, we want resilience, we want cost effectiveness, and there is nothing that I want to really leave out. But you'll notice that once you start to put these NFRs side by side, they are at healthy tension with each other. If you're building a highly performant, highly resilient system with redundant infrastructure, expensive hardware, it's obviously going to go against cost effectiveness. So there is that trade-off. And you need to have this trade-off conversation because you want to end up with what we call architectural characteristics, which is our second C. Right? So architectural characteristics are what I would call the non-negotiable NFRs that are disproportionately more important and vital to the success of your capability. And these are what define your capability and are separate from the aspirational non-functional requirements that you want to meet. These are critical for your capability to be successful. And you really want to chase a handful of these, literally something that you can count on one hand. Right? If you start to chase about 6 or 7 of these, then it becomes hard to engineer for. You may end up with an over-engineered system, or you may dilute their significance altogether. So really, you want to keep them limited so that you can target them and achieve them. So let's understand this with an example. So imagine a workload that's a trading system which has a capability for order management, which allows you to place trades. So here, you will have a conversation with your business and you determine that scalability, reliability, performance, and regulatory compliance are your critical NFRs that are your architectural characteristics. And in achieving these, you may need to trade off some other NFRs. You may need to trade off cost for the reasons that I mentioned before. So this is a complex engineered system, high-performance hardware, redundant infrastructure, and highly scalable, right? So cost is at odds with those qualities. Simplicity is nice to have for any system, but just the inherent domain that you're operating in here makes simplicity hard to achieve, right? So no matter how many technologies you can throw at it, it'll always be like a complex solution. Lastly, agility is another thing you may need to trade off, because when you're engineering a system for high reliability, high performance, and scalability, you want to ensure that any new changes are not causing any regression. So you want to meticulously validate any new changes, and that can result in longer release cycles, which is okay. We are prioritizing the effectiveness of those architectural characteristics and trading off certain other qualities. Now, underneath this, we still have the well-architected baseline, right? So well-architected is still giving you those architectural dimensions that every workload on AWS should have. But architectural characteristics take this a step further and enhance your capability for what sets them apart and becomes your competitive advantage. Now let's take a look at another capability within the same workload. This time, it's end-of-day reporting of trades, right? And this is something that is emailed to your traders before the start of the next business day or next market day. So in this situation, you are prioritizing cost effectiveness, you are prioritizing ease of implementation and ease of maintenance. And in achieving that, you may actually trade off scalability, right? You don't need your report generation to be massively scalable because you can batch them, right? You don't need the performance to be highly optimized because your users don't care how long it took the report to generate, just as long as they receive them in their inbox before the end of next day or before the start of next day, right? So in this case, a separate capability within the same workload is resulting in a completely different set of characteristics. And these capabilities come together to achieve the overarching goal of the workload. So as they say, the whole is greater than the sum of the parts, right? So in this case, the whole is your workload, and the parts are your capabilities. And I try to draw a parallel with a team sport like soccer, right? There are multiple players that make up a team, and each player has specific skills or technical attributes that make them successful for the role that they play in the team. Now, the coach of the team runs them through a standard set of drills to prepare them for match days with the intent of winning the game. And that's what I would equate to the well-architected framework. Each capability within your workload benefits from the well-architected framework equally. But beyond this, there are also individual drills that are catered to specific positions or specific roles in the team. So goalkeeper will have his own drills. The forward will have their own drills. So they'll take shooting practice, free kicks, and all of that. So these are what I would equate to capabilities and their specific characteristics. And together, these come, the players come to help the team achieve their objectives. Now, keep in mind that in a team sport, there is also this idea of a marquee player or a franchise player. You know that if that player has a great day, your team is more likely to win. Similarly, within your workload, you may have certain capabilities that are like your flagship capabilities. And the success of your workload depends on that one capability. So sometimes you may need to pay extra attention to certain capabilities, and you may find that you're investing more in that capability, which is normal. All right, so having said all that, how does this all tie back to AWS services? Right? We are, after all, here to simplify your technology choices when it comes to AWS services. So AWS services exhibit the architectural characteristics of our services just from the definition. So if you see the words highlighted here, you can see that Amazon S3 is an object storage service, and it offers scalability, data availability or durability, security, and performance as its standout characteristics. So if your solution needs an object storage, and if the characteristics that you're trying to achieve for your capability matches up with what S3 offers, then that's a straight fit. And you start to see this across our services. If I had $1 for every time I answered the ECS versus EKS question, I'd be pretty wealthy right now. But ECS offers simplicity of deployment, manageability, and scaling. So if you're looking for something like that within your workload, then ECS may be the right choice. Let's look at one last example. DynamoDB, fully managed serverless, high performance, high scalability. So as long as your data storage and data access patterns match what DynamoDB offers, and the characteristics that you're trying to achieve for your capability coincides with what DynamoDB offers, DynamoDB may be a good fit for your architecture. All right, so with that, you now know that you can use architectural characteristics to pick your services. We're taking a real jobs to be done approach here. So if you're familiar with that idea, you have a job and you're hiring a service or a product to do that job. And the job in this case is defined by the capability and the characteristics that you're trying to achieve for that capability. And you can always fire the service if the service doesn't do the job. All right, that brings us to our third C, which is constraints, right? So constraints are something that are inherent to a business or an enterprise, right? And these are things that relate to concerns like your budget, your timelines, the skills that you have on hand, any risks. So with that, you're usually, the constraints are beyond the control of the team that is building the architecture. It's just something that you need to learn to work with, because these are inherent to your business and not something that you can change overnight. And constraints come with a bit of a negative connotation, right? They impose restrictions on you, they reduce your flexibility, and they limit your options, right? But we want to also take another view on constraints. Constraints can actually be beneficial to you. So constraints encourage creativity in your solution. They promote frugality. A couple of years ago at re:Invent, Werner Vogels, our CTO, introduced the idea of frugal architect. So constraints actually help you be frugal with your architectural choices. And you may see that I'm saying limits options again as a positive. But in this case, what limits options is actually doing for you is it's simplifying your choices, right? It is narrowing your solution space and allowing you to arrive at your technology choices faster. If your constraints are outright eliminating some technology choices for you, what's remaining is what your solution space is, right? So this way, we are solving for that choice paralysis, and we are actually using constraints to our advantage. So these constraints are what I would call essential or inherent constraints of your business. But there are also artificial constraints or accidental constraints that sometimes get introduced. And usually they manifest in the form of enterprise guidelines. So if you are familiar with some statements that you see here, these are not uncommon at all, and it exists in pretty much every enterprise. Right? They usually enforce or restrict use of certain technologies, certain architectural patterns. And most likely they exist with, most commonly also, they exist with very good intent. Right? These are based on some past research, some past evaluations, some past experiences, or an effort to standardize. But what they can also result in is they are imposing restrictions on you artificially, and you're not able to solution for the capability the way it would result in the best solution. So what we recommend instead is using your 3 Cs, capabilities, constraints, and characteristics, to arrive at your technology decisions, and then evaluate them against your enterprise guidelines. If your enterprise guidelines are actually improving your solution, by all means, borrow from your enterprise guidelines. I'm by no means saying go have a fight with your architectural review board, throw away all the guidelines. No, no. They are still very important, right? But what we are promoting is this idea that don't let them set in stone and stand back in a time that has not moved, right? Your enterprise guidelines can advise your solution, but any new discoveries that you make through your 3 Cs and the intentionality that you have established behind your technology choices, those new discoveries should feed back into your enterprise guidelines. And that way, they don't stay stagnant, and they are continuously evolving as well. So it's very common that enterprise guidelines are outdated or something from 5 years ago and not fit for the purpose anymore. This is an intentional forcing function for you to continuously evolve your enterprise guidelines. And it can be really serendipitous when this happens. All right, so we've taken all this time to establish the intentionality behind our architecture. We don't want to skimp on the last step, which is an important step. Us as technologists are not very fond of documentation, right? But what we are suggesting here is not write pages of documentation, but instead use a concept that most of you are likely already familiar with. And that's the idea of architectural decision records, or ADRs, right? And ADRs are this lightweight ways of documenting your architecture. And I say that ADRs and an architectural diagram is all you need to document your architecture. You don't need pages of documentation in a Confluence page or a wiki to understand your architecture. So for those of you unfamiliar with ADRs, I want to just run through what makes up an ADR. So you would start with the title. And here you define what your architectural decision is for. And here you can specify what capability you're trying to achieve. The status goes through different stages like proposed, under review, accepted, or rejected. And rejected decisions are also good to have around because you don't want to go through that same evaluation cycle again if something was already evaluated and rejected. And if the ADR is no longer required, it can also be deprecated. The next stage is the context, where you actually describe your problem statement in detail. And here you specify all the things that are governing your decision. And lastly, in the decision, you actually specify what you're using as your technology choices, the ultimate decision that you ended up making. And along with decision, we also want to document our consequences. What are the consequences of this decision? What are the trade-offs you had to make? What are your fallback options if the decision doesn't pan out the way you expected it to? And in some cases, you would have evaluated some alternatives. It's useful to document them too, because those could be your fallbacks. If something closely lost out to the ultimate decision, if the decision doesn't pan out, that alternative may become your actual architectural choice, right? In addition to these standard ADR fields, we also recommend documenting some additional fields. So we recommend documenting the stakeholders who were involved in making the decision, the actual people who were involved in coming up with this decision, because these decisions are never made by one person. So even though you are the architect, you likely did not come up with this on your own. So usually there's a product team involved, engineering team involved, architecture involved. So put the names of the actual people who were involved in making the decision. That also sets some accountability and conviction behind the decision. And if you ever need somebody to blame, you know where to go, right? Additionally, we also recommend documenting your characteristics and constraints as separate fields. You could, of course, have them stated within the context as well. But sometimes, if the context gets very verbose, they can get lost in there. So if you surface up your constraints and characteristics as their own field, it creates a shared understanding of what drove this decision in the first place. All right, so having said all that, let's walk through a practical example. And we'll take a workload like e-commerce system and pick a capability, which is product catalog. So for the product catalog, our business intent is that we want to offer a diverse collection of products with best-in-class user experience. And for this, we have had a conversation with our business and determined that the architectural characteristics of scalable, reliable, and performant are going to be really important for this capability to be successful. This is what will lead to the adoption. We're also working with a couple of constraints. We want to use containers, but we have very limited containers experience of running workloads in production. We also want to support a wide variety of products across many regions, and we are not selling only particular types of products. So with that, we arrive at our architectural decision. First, let's look at the alternatives. So we start with the idea of serverless first, but we believe that millions of users will use this capability on day one, and they'll use it around the clock. So we feel like provisioned compute with auto-scaling will work better. But we want to use a containers-based architecture. We do not want to directly deploy on VMs. But we do not have any Kubernetes experience because we only really getting started with our containers journey. So that's the compute aspect. For databases, we evaluated relational databases. And we found that our product schema, because of how many different types of products we want to support or how many regions we want to support, it was very hard to standardize on a data model. So we ruled out relational databases temporarily. And for storage, we evaluated network file system. And we are mostly dealing here with static data like product images and product videos. And because of that, we found that network file systems were not working out, were not being very cost effective. So what we ended up with in our actual solution, we still went with a containers-based architecture, but we picked Amazon ECS with Fargate. So it gives us the scalability that we need, and we can also engineer our applications to be reliable and performant. In addition to that, we chose NoSQL as our database because the characteristics offered by DynamoDB matches up with the characteristics that we are trying to achieve. And we are able to make the data access patterns of DynamoDB and the data shape of DynamoDB work for us. And lastly, we went for an object store because object stores are well optimized for static data. And Amazon S3 offers the characteristics that match up with the architectural characteristics that we want to achieve. So this way, you see how we can go from a workload distilled to a capability, use our 3 Cs, characteristics, capabilities, and constraints to arrive at our architectural choices. Let's quickly reinforce this with another example.
Yeah, I think in the interest of time, what we'll do is you saw in detail how Sushant walked through one example. So you can take another example of something like Amazon Rufus. You might have been using Amazon Rufus to help you shop. So let's say an e-commerce company wants to build in that capability, and the architectural characteristics are that it needs to be cost-effective, maintainable, and agile, with the constraints that you have limited in-house AI/ML skills, and you don't have too much time because guess what? Today is Cyber Monday, right? So given these 3 Cs, of course, you can evaluate between whether to self-host them or not because you don't have the skills. You would rather settle with Amazon Bedrock. And then similarly, you don't want to be building and maintaining a commercially vector database, so you'd rather use Amazon Bedrock. So this is how we arrive at decisions. You can probably take photo of this just as to show you how to practically apply this, right? Next, one of the common questions that we get is, all right, we have workload, we have multiple capabilities within the workload, and these capabilities can have conflicting characteristics. Then how do we go about reasoning them, and how do we make sure that the characteristics don't cancel out each other?
Yep, that's a very vital question. And you can have multiple capabilities within a workload. And if they have the same set of characteristics, they usually work together to achieve the common objective. But when they have conflicting characteristics, for example, if capability A is optimized for performance and capability B is not, capability B can actually weigh capability A down. And they communicate through well-defined interfaces. So a couple of ways in which we can solve for this is we still have the well-architected baseline. So this is uniformly affecting all your capabilities, influencing all your capabilities. So they should really not be too far apart from each other. But in addition to that, you've already optimized capability A for performance. So capability A needs to protect its characteristics. So that brings us to our next concept, which is isolation boundaries. So isolation boundaries are a conceptual idea that allow each capability to protect its characteristics even when they are interacting with other capabilities, right? And these can be implemented in many different forms, right? There are things like circuit breakers, exponential backoffs and retries, queuing, asynchronous communication, and you can even do it through your application code. But know that good fences make good neighbors, and similarly, isolation boundaries help capabilities protect their characteristics. The next question we often get is, everybody understands ADRs are useful, and there is consensus around their usefulness. But many organizations have a problem either getting started with ADRs or continuously, consistently doing it over a period of time. So how we go about that is when we'll talk about next.
Yeah. So ADRs is easier said than done, right? Of course, we all hate documentation, so it feels like that additional effort to actually get started with the ADR process. But here are simple 3 tips that we have, synthesized here based on what customer journeys we have seen on AWS. Start with simple cross-functional teams because you need to have that dialogue with business, with product and engineering, and also the business stakeholders, so that we know what capabilities we are building for that system. And then keep the team lean. You don't want to build a big team and get stuck in making decisions. That's not the intention of it. It needs to be a lean cross-functional team. The second aspect is around the process, right? So there needs to be a process to store these ADRs, and most importantly, it needs to be centralized and accessible. And third important thing is it needs to be version controlled because you can actually see the evolutionary trail, right? You need to be able to see how you have taken decisions over a period of time. And lastly, governance, right? After all that is said and done, if you just put ADRs and a bunch of ADRs in a wiki page, that might not necessarily everyone follow those guidance, right? So you need to be able to enforce these ADRs, and the way to do it is, simple things like leveraging AWS services, like AWS organizations, and service control policies, where you can control which services can be launched within a particular AWS account. Additionally, you can even use services like AWS config for driving more granular enforcement, right? So the next question is that we commonly get from our customers when we discuss this framework is, does this apply to greenfield? Does this apply to brownfield? And how do we go about reasoning with those two scenarios?
Yeah, so this framework is equally applicable to both greenfield and brownfield solutions. But the way you approach these characteristics is going to differ, right? So in a greenfield capability situation, you are mostly working based off of projections and doing what we call qualitative analysis. You work with your business and identify the architectural characteristics to build your capability, but nobody has really used your application in production yet. So you don't know the real usage patterns or how your application or capability will actually be used in production. So until you are actually in production and seeing that usage, you are mostly working based on projections, and you're definitely going to do some market research to arrive at your architectural characteristics, but you are kind of hoping that you made the right choices. With brownfield, you actually have well-defined metrics and usage patterns already established in production. So if you optimized your capability for scalability or performance, you know exactly what level of scalability and performance you're getting today. And if you improve that, if you need to improve that, you have a baseline to go off of. So this time you're using real metrics, and that gives you the ability to use quantitative analysis. And that way, brownfield can sometimes actually be an advantage. So I know as engineers love to work on greenfield solutions because it gives us a blank slate to implement all our ideas. But brownfield has also its advantages compared to greenfield, right? So with that, we have the opportunity to still break the workload into capabilities the same way in both brownfield and greenfield. But the way you determine your architectural characteristics will be different for greenfield and brownfield. In fact, if you don't have your workloads broken out into capabilities today in brownfield situations, after today's session, maybe a time to go revisit and see how you can break down your large workloads into smaller capabilities.
Perfect. So now that we have seen this framework on the 3 C's, let's bring it together, right? So always start with capabilities, right? And the default reaction and the default trend we see is starting with technologies. Please don't do that. Start with capabilities and pay extra attention to those non-functional capabilities, because we are proposing that those needs to be your first-class citizens in this approach, right? Second, extract the characteristics from these capabilities, and again, make sure that you are not picking too many characteristics, and like Sushant mentioned, just keep it a single handful, right? And after you have the characteristics, you're then going to be shortlisting your technology choices. As you can see clearly, it's not until step 3 you're thinking about any specific technology. So that's when you shortlist your options. And when you do shortlist your options, keep in mind the decision framework of, factoring in the enterprise guidelines with the 3 C's. That is something important to keep in mind. And then you arrive at your architectural patterns depending on your business. And the most important thing to do here is that the job is not done when your architecture is decided. That is actually when your first iteration begins, right? You got to evaluate your architecture. Like we said, architecture evolution is a continuous process. So by doing this over and over and over again, you're going to be able to evolve your architectures more organically and more consistently over a long periods of time, so that it will quickly and dynamically support any business outcome, right? So with that, recap, the final slide, right? So as you finish your week here at reInvent, I know you're going to have tons of information about new products and services and features and solutions and yet another architectural pattern. But the first thing we would love for you to do is start shifting that mindset to start looking at your architectures as living systems, one, and then recognize that there is an evolution that is going on. Is that reactive? and is there something that I can be doing proactively? So have a plan for evolution, step one, right? And let capabilities be anchored at the center of your architectural evolution. Like we have discussed before, it's not technology, it's the 3 C's and capabilities, right? And then have a plan to evolve incrementally and proactively. And ADRs, we've provided some tips, so please get started on ADRs. We are actually starting to see customers build knowledge base-based ADR applications, so who knows, that might be the easiest thing to actually build. And lastly, consult with your AWS account team, right? So we as AWS architects, we get to see what works and what doesn't work when we look at thousands of customer journeys or AWS. So we have learnings from all of this, and we are here to share that with you. So please consult with your AWS team. And remember, at the end of the day, what matters is a disciplined approach to architectural practice, focus on capabilities instead of technologies, and consistency of approach to evolve the architecture. So that's what matters. So with that, thank you very much. We would appreciate if you can pull up your phones and provide feedback. And lastly, if you want, so this is the framework. We also do a workshop around this. So if you feel like this workshop would benefit you to apply this framework to your particular use case, you can reach out to your account teams and they'll facilitate that. And lastly, if you would like to see an ADR kind of a tool within your AWS console, please indicate so in the feedback, because who knows, next year we may just have it, right? So with that, thank you very much. We'll be available in the hallway to my right or to your left if you want to have any further discussions. Thank you.
Thank you.